Hello everyone, I am Shweta from GMR Polytechnic Gajwel. My video lesson on data communication and computer network subject for 5th semester students. Today I am going to teach you the basics of data communication. In this we will discuss what is data communication and need for data communication, and what are the elements in data communication, and what are the fundamental characteristics of data communication, and differences between analog and digital data. So these are all topics we will discuss today's class. So first of all, what is a data? Data is nothing but information. So in this information may be either it is analog information or digital information. So example for analog information is amplitude of the human voice or room temperature. Examples of digital information is nothing but status of any electronic devices, that is either on or off or Morse code. Next, first of all, just before going to start the topic, so first we will learn the introduction to data communication. So the subject name itself, it says that data communication and computer network. So in case of digital communication, the information can be easily processed, multiplexed, as it offers high signal to noise ratio. That means in case of digital communication, or we will transfer the data in digital form, the noise will be reduced compared to analog signals or analog data transmission. So how can we send the data from transmitter to receiver? We will use a transmission channel or transmission medium. So by using that, we will transmit the data to transmitter to receiver or source to destination. So in case of digital communication, one can send the analog information such as human voice, video, pictures, information or music or digitals, or alphanumeric codes, graphics, symbols, database information and binary coded numbers at a faster rate by using a digital communication. But in case of analog communication, we can't send the data as fast as possible, and also some noise may occur. Next, in digital data transmission system, we require a physically facility. So a physical facility between the transmitter and receiver. So by using a physical transmission media, we are sending the data from transmitter to receiver. For that purpose, here we are using a cables. That may be different types of cables are there. Either it is a coaxial cable or fiber optic cable or wire pair cable or metallic cable. Whatever it is, we can use. Even though without using wire also, we will send the data. For that we use by using a wide, we will send the data. We call it as a wide communication. Without wire, we will send the data, then we call it as a wireless communication. So here the wireless communication is used in case of radio systems. Here the channel is the space, channel is free space or earth atmosphere. So in data communication, we have two types of data communications: wired communication and wireless communication. In wired communication, we will use the wire as a channel. In wireless communication, free space as the channel. Okay. Next, first of all, what is a data communication? So here the data communication is nothing but a exchange of the data between the source and receiver. So data communication is said to be local if both transmitting and receiving devices both are in a similarly geographical area, then we call it as a local communication. So first of all, what is data communication? Exchange of the data between the transmitter and receiver or source and receiver is called as a data communication. When we call it as a local communication, both transmitter device and receiving device both are in a similarly located geographical area, then we call it as a local data communication. So here the meanings of source and receivers are very simple. Where the device that transmits the data is called as a source, the device which receives the data is called as a receiver. Okay, next, communication model. So the communication model consists of mainly 5 things, that is source, transmitter, transmission system, receiver and destination. So first of all, what is a source? Source is nothing but which is used to generate the data to be transmitted. Next one is a transmitter. So transmitter is used to convert the data into transmittable signals. Next one is transmission system, which is used to carry the data. So by using this, we will transmit the data from transmitter to receiver. Next one is a receiver, so which is used to converts the received signals into data. Here we are using the transmitter and receivers. These two are for conversion purpose, like encoder and decoder. Okay, next one is a destination, which takes the incoming data. So mainly the communication model consists of 5 blocks: source, transmitter, transmission system, receiver and destination. First of all, what is a source? Source is used to generate the data that is to be transmitted. What is transmitter? Which is used to convert the data into transmitted signal. What is a transmission system? Which is used to carry the data. What is a receiver? Which is used to convert the received signal into data. Next one is a destination, which takes the incoming data. So this is the simplified communication model diagram. So here we have 5 blocks. The source and transmitter is called as a source system. Receiver and destination is called as a destination system. Middle one is a transmission system. By using this transmission system, we will send the data from transmitter to receiver. So here source and transmitter, these two are used to transmit the data. First one is source to source. This is used to transmit the data to the transmitter. Transmitter is used to convert the data. Again here the transmission system. Transmission system is used to transfer the data, like it works like a channel. Next one is a receiver. Receiver again converts the data. Next one is a destination. By using this destination, we will receive the data. This is the simplified communication model diagram. Next one is basic elements of data communication system. So the basic elements of data communication system mainly consists of 5 components. So these are message, sender, receiver, medium and protocol. So these are all like to send the data to transmitter to receiver. Okay, so we have already discussed about what is message. Message is nothing but a information that is to be transmitted. Next one is some transmitter and receiver. Next one is a transmission media, that is nothing but a channel. Next, last one is a protocol. So protocol is nothing but set of rules that governs the data communication. So what it means is nothing but which is an agreement between the communicating devices. Okay, so communicating devices are nothing but what? transmitter device and receiver device. These two devices has an agreement. Okay, for this, by using this protocol, the data has to be transferred. So here, without a protocol, two devices may not be connected. Two devices may be connected but not communicated. So how? Because if two persons are there, so one person knows only French, another person knows only Japanese. So without a mediator or without a knowledge of these two persons, one person has to understand French and Japanese, another has to same. So without just like a person speaking French cannot be understood by a person who speaks only Japanese. So this is the situation. So without protocol, we can't send the data to the transmitter to receiver. Both devices may connect, but they can't transmit the data. Here also same. Two persons may present, but they can't understand what he is speaking, what another person is speaking. So first of all, what is a protocol? Protocol is nothing but a set of rules that governs the data. So this is an agreement between the two communicating devices. Okay. Next one is a fundamental characteristics of data communication. So the fundamental characteristics of data communication mainly depends on delivery, accuracy and timelines. So in this, first of all, what is a delivery? So the system must deliver the data to the correct destination. So that means the destination address we have to must maintain. Okay, so the data must be received by the device or user. Next one is accuracy. The system must deliver the data accurately. Next is timelines. The system must deliver the data in a timely manner. Okay, without these characteristics, even though we will send the data also, without these characteristics, if we send the data, that data need not be useful. Next one is need for data communication networking. So in data communication networking, we have to perform the following task. First one is signal generation, synchronization, transmission system utilization, error detection and correction, flow control of data, addressing and routing. Okay, so in this, first one is a signal generation. So both the communicating devices must be able to generate and receive the signal. Okay, here the generated signal has to propagate through the transmission medium, and that signal is received by the receiver. Okay, next one is synchronization. The receiver and transmitter must be synchronized. Unless the receiver will not able to understand the transmitted signal at the receiving end. So receiver has to know data, when the data has when the transmission of data, when it starts and when the data ends. Next one is transmission system utilization. So the transmission system utilization here refers to make efficient use of transmission channel, which are generally shared by many communicating devices. Next one is error correction and detection. So in communication system, we used error correcting and detecting methods for correcting and detecting of the errors. So we have a for error detection method, parity checking, LRC, VRCs are etc. are there. In error correction methods, Hamming codes, ARQs etc. So these are all discussed in digital communication. So no need to here discuss again. Once you check all the correction and detection methods. Next one is a flow control of data. So here there is a possibility of transmitter generating the data faster than the receiver device capable of handling. So for this purpose, if there is a possibility of So for this purpose, to handle this should be some kind of data flow control mechanism agreed upon between the two communicating devices. Because if one, suppose a transmitting device is transmit the data, okay, receiving device may not be have a capability to receive that data. So then that time what will happens, there is no need here, the data may loss, okay. So for this purpose there is flow control of, for this purpose we have an agreement or control, data flow control mechanism agreed between the two communicating devices. Next one is addressing, okay. When more than two devices share a transmitting facility, a source system must indicate the identity of the destination, okay. Without a destination address we can't send the data to the correct destination. Yes, the transmission system must send the data to correct destination by using this addressing. That's it. Next, routing. So without route also we can't send the data. So here the transmission system must ensure that the data sent or routed only to the destination system. So by using router we will send the data to the exact destination position. Next one is, what is analog and digital signals. So first of all, what is analog signal? A signal which is a continuous with respect to time is called as a analog signal. So examples of analog signals are sound signal, video signals are examples of analog signal. Next, what is a digital signal? A signal which has a discrete values are discontinuous with respect to time is called as a digital signal, okay. So in this, first of all, analog signal is nothing but a continuously varying signal like a sinusoidal waveform. For example, the output of microphone, when a speaker talks over it, it will be sinusoidal wave that varies with time, okay. So it has a amplitude, frequency, phase and a definite bandwidth. So these are the examples of analog signals which has a which is continuously varying with time, which has frequency, amplitude and time. Once check it. Next. So when the sinusoidal signal is transmitted over a wire or any channel, the noise may get added to the amplitude of the signal, okay. So the analog signal may be distorted due to the noise and transmission media properties, okay. Next, okay, here when the analog signal is distorted by the noise, we cannot reconstruct it even by using amplifiers. So what is here, what is the purpose for amplifiers? Amplifiers are just boosting the signals but not eliminate the exact noise, okay. So these are another example of analog signal. This is also like an analog signal. So it has a time, intensity, space. This is a analog signal. Next one is a digital signal. So a digital signal is of a continuous nature in the form of discontinuous nature in the form of pulses, but in case of analog signal, that is continuous nature in the here the discontinuous nature. So the absence of pulse we call it as a 0 and the presence of pulse we call it as a 1. So during the transmission of pulses, even if noise gets added, it will not create a problem. But in case of analog signals, the noise may get added and it will disturb the signal. So this is because of the demarking of 0 and 1 with respect to a threshold point. So these are the digital signals. So this is a digital signal. When the signal is present, this is represented as 1. When the signal is absent, that is 0. So differences between analog and digital transmission. So first difference is analog data taken on continuous values on some intervals, digital data taken on discrete values. Analog signal is a continuous signal, discrete signal is digital signal is a discrete signal. Next, analog signal occupies the same spectrum as the analog data. Here the digital signal consists of two voltage levels to represent the two binary values. Here we use two binary values, that is 1 and 0. So to transmit the analog data over a long distance, amplifiers are used to boost the energy of the signals. So in case of digital data transmission, we use repeaters. In case of analog, we use amplifiers like this. In case of digital, we use repeaters. Next one is analog transmission is a means of transmitting analog signals without regard to their content. In case of digital transmission, is concerned with the content of the signal. So here the noise level is more, here the noise level is less. Transmission system cost is more, here the transmission system cost is less. Transmission speed is less, here the transmission speed is more. Transmission power requires are more, here the transmission power requirements are less. Next, distortion and the noise interference are cumulative over the entire transmission path. Here the distortion and the noise interference are cumulative. Here the bandwidth requirement is less. In case of digital, the bandwidth requirement is more. So these two are, one is a digital signal, next one is an analog signal. So we have discussed about definition of data communication, need for data communication networking and elements of data communication and characteristics of data communication. Next, distinguish or differences between analog and digital data. These are all we have discussed. So some quiz. The effectiveness of data communication mainly depends on what? Accuracy, delivery, timelines, all the above. Answer is D. Next, some frequently asked questions. Define data communication and what are the fundamental characteristics of data communication? What are the components of the digital communication? Distinguish between analog and digital data. Thank you.
మమ్మీ ఎందుకు నాకు నన్ను అడగకుండానే పోయినావు నీకు వచ్చిన అంత వెతికినా
Yeah, 1 minute video.